Hello, everyone. I think we're going to start the panel, the last panel, very soon. So you could just find a seat, and we'll welcome the panelists to the stage. Can you please display the panel? Yes, thank you. So let's welcome the panelists to the stage. Yeah, thanks, everyone, for sticking around for the almost last agenda for this really interesting summit. We have a very interesting topic to close the event, which is going to be on the impact of foundation models or LLMs on software quality. And we have a pretty strong panel as well. So I'd like to ask the panelists to introduce yourself first, and then we can start the discussion. Would you like to start first?
Well, I already introduced myself this morning. I gave a talk, so I'm not sure that's necessary. But so.
Well, in case you forgot since yesterday, my name is Ipek Ozkaya, Software Engineering Institute, Carnegie Mellon University.
My name is David Low from Singapore Management University.
I'm Foutse Khomh from Polytechnique Montréal.
This is Lei from University of Tokyo and University of Alberta.
Khurshid, University of Texas at Austin.
Awesome. Thanks, everyone. Okay, so we can dive right in. So as we were talking just a few minutes before, I do think this panel topic actually covers a wide range of things that we can be talking about. There are quality issues for foundation model applications, quality assurance for the model itself, and also we can use the model to ensure codeware quality, etc. There are many different aspects that we can dive into. But I think we can start from one of them, which is the quality assurance or software quality for the new type of software that has a foundation model inside as a component. My first question would be, how do you think we can define what is quality for this kind of new software? Does the definition stay the same for neuralware and codeware, and then to the new agent and promptware, or are there new dimensions we have to think about? Anyone?
Well, that's a vast question, but I'll try to tackle it from a specific angle. I mean, those components, like deep neural networks before them, when they are integrated into AI-enabled systems, are inherently uncertain. I mean, you can't ensure, even with a high level of probability, that they are going to provide you with not only correct outputs, but outputs that will be safe for the system that integrate them. So that means you need an architecture where you ensure that those components cannot have any negative side effect on the rest of the system. So if it's a system where safety is important, you need a safety monitor, something that wraps those components, make sure that what they produce cannot in any possible way harm the system with respect to safety or other characteristics. Whereas before, I mean, we couldn't be certain that a particular component was correct, but at least it could be verified in some way. It could be reviewed. It could be code reviews. It could be, the logic of the component could be carefully analyzed, and the contracts of the component could be defined. And here none of that applies. So you just have to protect yourself, basically, against any possible harmful output.
So I think there are two aspects of quality. One is from the perspective of the specifications, the goal that the product, the system has to satisfy. That probably does not change much because we have techniques in terms of expressing what we expect from the output and then checking against that specification. However, there's a conformance aspect of quality as well. So we talk about code conformance. We have particular language rules which is made up of its intrinsic quality. From that perspective, there's probably work to be done. What does it mean to have intrinsic quality for a product that is just made of data and you express it through prompts? So I think that's maybe an open area of work that will need some more thinking. But from the perspective of the needs of the end user and how those are checked against, it's an input and output, and some of our existing techniques will definitely still apply in the different kinds of products as we develop with the large language models and foundation models.
I think there is a number of interesting quality aspects as well. For example, there is this thing of robustness. So basically, we want the output to not differ very much when we change the input a little bit. And I think with this deep learning and large language model, it becomes more important. And also there is this aspects of security that maybe previously wasn't considered on traditional software. When we bring AIware into the picture, when there is an LLM and also traditional software put together, then I think there is additional security problems. For example, the data that actually is used to train the model may actually introduce a backdoor. And thinking and comparing the traditional software and LLM, one interesting thing is that actually LLM is like a software with a lot of bloat. Meaning there's a lot of things that actually is not needed for the functionality, but it's there, right? It's pre-trained in all the weight of the LLM, especially for large models. And we are not careful actually with certain prompts. Those behaviors that are hidden in the LLM can actually be activated and create quality problem. And that's why there is this also how to actually create guardrails to prevent people from doing bad things with the LLM. But there's also techniques like jailbreaking to actually go through that particular guardrails and then cause the LLM to do something that is bad. So I think there is many new nuances of software quality also when LLM is being considered that are exciting for us to explore together in the FM plus SE era.
So I totally agree with what have been said before. I think the foundation models, they actually somehow compress a lot of knowledge. So when we embed them in applications, they usually are capable of some emerging behavior that may not be necessary for the application, for the use cases of the systems. So I think it's very important that we have a good understanding, at least, of this potential side effect of the model, so that we provide the appropriate guardrail around, safety net around, to kind of control the behavior of the model. And I think one thing in terms of techniques it's more important in this context than maybe was not necessary in the traditional software is that we need a good understanding of assessment of uncertainty on the behavior of the model, right? You need to be able to do good uncertainty estimates so that you can react on this type of property when you quantify the behavior of the system. Another aspect that comes from the fact that they are purely data-driven is that I think new quality dimension emerge, things like fairness issue, right? So in traditional software, in some cases, we're not that much concerned about this type of unfair behavior of the model, of the system itself. But because we have something that is purely driven by the data and the quality of the data can actually emulate some unwilling behavior through the model, it's important also to test for these new additional dimensions and to have proper techniques around the system to ensure that the services align with the intention. So I think uncertainty estimation, alignment issues, good understanding of the behavior and controls around the models. To me, I see new things, new requirement that comes with this type of problems. Yeah.
Yeah, so I think we can try to think about this in two directions. So one is that for traditional software, actually, I think we have been have the theoretical foundations, and also for the industrial practice, they have been there for quite a long time. And I remember there is a software metrics books with this thick, thousands of pages, and there's a lot of metrics already well defined inside to measure different aspects. Some of them through the progress and over the years of industrial practice, some might not be some use are more often compiled with others. And like some of the ISO standard on quality assurance, ISO 25000 series, there are very specific definitions on what the like a quality aspect should, quality models we should look at into. I think they are very clear. The thing changes a little bit is, that's the second point, that when the new data-driven program paradigm comes, the large language models in particular, that creates a new application space and capability that we don't have that strong capability by traditional software decision-based logic in that sense. And some of the technical challenges so far then transformed a little bit to different angles of the quality aspect or trustworthy aspect, even we're using different terms. So we focus some of the aspect more compared with traditional software. And some of the terminology, as we have discussed like yesterday and today, even not consistent from my point of view. Like from the robustness in traditional software system, it means yeah, that kind of thing. But robustness in the AI models is more on the like adversarial attack and point of view. So I think this is when we move forward, we need to consider both these things we have already, and also think about what the new challenges and the new safety requirement we have, so that to think about the better solutions forward.
Thank you. So just to complement what's already been said, I think, well, I'm going to talk a bit about correctness. So fundamentally, the question remains the same, that we have some expected behavior and then we have some actual behavior, and then we want to check whether the actual behavior conforms to the expected behavior. But now, of course, the actual behavior is coming from either a traditional style of programming or some code which might have been created, or some code that we have just no visibility or understanding about. So the issue then is that how do we check for this conformance? And if we look at like some of the traditional work that was done, for example, in formal methods or in model checking, so one of the sort of the driving, motivating elements over there was to look for these subtle, hard to find bugs, which don't appear in some of the common cases, but might be there, and how to look for them. So now if you look at the current setting, the problem has become, in some sense, much worse. How do we look for these hard to find or subtle bugs in, let's say, a deep neural network? And then what even the definition of a bug is. But I think one technique which comes from the traditional world, which still has a role, is runtime monitoring or runtime error recovery. So if we can put some guards, or like, as David said, some guardrails, that could certainly help handle certain failures. But still there is a lot of interesting work that needs to be done in terms of gaining confidence in the correctness of the system. And which means there's a lot of research to be done. So that's very exciting.
Yeah, thanks for the comments. So I think from everyone's answer, we definitely see that there are the correctness perspective of the quality, and then there are several trustworthiness or non-functional requirements that were mentioned, including robustness, safety, etc. So we know that in the past few years, people or the field has been focusing on trying to resolve this for conventional deep learning models or other machine learning models. And now that we're in an era of foundation models, we do see standardization efforts like ISO standards. They were trying to catch up, right? They defined the software quality attributes, and then they defined a new standard, I believe, in 2023 for AI systems software quality model. But that was still based on conventional deep learning or machine learning models. Are we seeing new challenges for these kind of issues compared to those deep learning models for foundation models? For example, one thing I could think about could be that now I do believe that testing for foundation model correctness, if we start with the correctness, how do we even specify the expectation already becomes a problem, because the output space becomes really large and indefinite rather than certain limited prediction or regression numbers. Do we think there are new issues emerging for this kind of new type of models compared to conventional models?
Did I understand your question correctly that, now we're going to overuse the word correct, the correctness of the foundation model, is that a concept that you're suggesting we think about, or?
We could start with correctness. Then there are other non-functional requirements as well, but if we even start there, I do think I feel like there should be some new challenges that we're seeing right now compared to other deep learning models we're seeing, right? As an example would be how do we specify them, and are we seeing more flakiness for this kind of new models because of its non-determinism inside?
Well, I think we confuse ourselves because of what are the building blocks, right? What's the minimum element of the building block? Maybe we could talk about properties of that particular element, and then when multiple of those elements come together, how they influence each other and how the attributes got influenced. So we should not probably lose track of that. And we're talking about either the data and the property of the data, and then when we have large amounts of data, how they act together, and then the task at hand and questions being asked and the responses that come out, and how does the task and tasks attributes are influenced. So maybe there's a hierarchy of attributes that we need to think about. So I'll maybe stop there and come back to it.
I think we have to accept the fact that large language models, like deep neural networks before that, they can neither be specified nor shown correct. They cannot be specified because what they do is so complicated. It cannot be precisely specified. It's like trying to specify what a system to avoid collisions with a pedestrian should do. You cannot precisely specify this. Oh, you can have safety requirements, yes, things that should not happen, but you cannot specify what it does. I mean, it's just not possible, and it's true in general of those models. So, and of course, obviously, they cannot be demonstrated to be correct, even though a lot of formal verification people claim the contrary. But when you look at it more closely, it's just not possible. So we just have to accept that, and given that, the question is, what do you do? You know, and well. I mentioned just before, one thing you can do is to monitor what the output of the components, and make sure it doesn't harm the rest of the system, never, ever. And beyond that, you can retrain, fine-tune on a regular basis to make sure you maintain its capability over time. And I don't know what else you can do, but anyway, you can neither specify nor demonstrate that it's correct. So if it's not acceptable, then you shouldn't use it, you know.
Yeah, I fully agree with the comments from Ipek and from Lionel. So I think Lionel mentioned like the scale. So large language model is really large in size. And I think that creates a lot of problem that the current tools cannot handle. For example, I think there are tools that can do verification, for example, of neural network, but it's limited in the number of layers, number of neurons. But these large language models go to billions of parameters, and are we able to scale up the current verification methods to deal with that? Another problem is that I had a very nice discussion with Ahmed also that compared this large language model like a database. And imagine having a big database, and the code that accesses that database is actually very prone for SQL injection attack. Then actually it's very good for an attacker to actually gain a lot of data. So with large language model, there's a lot of data, and that data may not be protected. And now there is a lot of standards. I think, Dayi, you mentioned like standards, maybe in Europe, there is, for example, there is a GDPR standard, there is additional standards that are just on, I think, the AI Act. And also there is this rights to be forgotten. And again, the question is with a lot of data there, let's say we want to do machine unlearning. Can we really unlearn when the data is like terabytes inside that are put inside the large language model? We do not know which parameter of the large language model. So I think it creates a lot of privacy issue as well that I think the current solution cannot fully address yet, but it will be an exciting direction of future work. Just my 2 cents there.
Yeah, I fully agree, and I think what's currently people do, that's why we're seeing this proliferation of different benchmarks. They try to assess the capability of this model for different specific tasks. Right? So in a sense, if we're building a system and we're using them to emulate certain functionality of the systems, I think one thing we could do is looking at that functionality that we're emulating through the large language model as a specific task, and then we can actually study how well the foundation model that is used to power that functionality, it's able to satisfy that, to carry out the current task. And on that sense, I think some benchmarking could help in that sense. If we clearly specify what are the tasks that we're interested in, we can benchmark, and then when we're satisfied with the behavior of the foundation model, we get some confidence on the ability of the model to power the functionality in the system. So I think that's maybe one way that I see that we can increase our trust in the resulting system that it's built on that building blocks. And then I think we need guardrail around it, right? When we know what the task, because I think one problem with language model is that they are by design built to emulate different type of behaviors, not just a single behavior, which means when we interact or when multiple components interact, there's likely to be emerging behavior from this. And those emerging behaviors can cause side effects in the systems, right? And they can actually provide some backdoors and some different access on the system. So it's one thing to ensure that we're getting the functionality, but I think it's also very important to understand what happens when these components are interacting and when we are actually accessing the model to emulate the functionality. And we can do some testing maybe at that point as well to make sure that we really understand this feature interaction thing. So there are things that we can actually leverage from traditional software engineering practices to increase our confidence in the behavior of that piece of component that we're building, I think, yeah.
So regarding the quality models, I think the development might need some time to try in different kind of domains and gradually sync and some kind of common kind of a metrics will show up. And one big challenge I think for nowadays AI is that it's a very, very fast speed. It's being tried in so many different application domains. And there will be a lot of different kind of concerns in different aspects. And the information volume is also so huge, it's really hard to be consumed by just one or few parties. So I think there's a really big challenging, even for a lot of standardization parties, that to think about how can we actually try to make all these things common and have a very basic shared understanding on the same stuff.
So I guess what I would say is, like, in terms of, for example, specification, yeah, it's completely correct that it's very, very hard to specify anything. For example, if you try and characterize what is the expected behavior of ChatGPT, I mean, okay, good luck. But then, that's not a big issue in itself. I mean, we can look at how ChatGPT is being used, for example. So, if it's being used in a particular context, let's say to create a code segment, which is going to be used as a part of an application, now we can look at, like, what about the correctness of that application? Because now, in some sense, whether ChatGPT was correct or not, we can defer that by checking whether the code that it created, now once we use it in the application, whether the application works correctly or not. Okay, so it's not that we need to sort of have sort of a comprehensive thing of guaranteeing that these LLMs are sort of working correctly, but when we use them, we need to use them in somewhat of a sensible way. And then even, this question about correctness, it doesn't even have to be in the context of this something as complex as ChatGPT, but even if you think about, like, some deep neural network that's supposed to recognize cats in a picture. So how do you specify a picture that has a cat in sort of a precise way? So, you know, it's just that by nature of where these deep learning models are being used, if you only look at what the purpose of the model is, they are trying to solve these problems that are inherently very hard to specify formally. But that's, again, not a huge problem just by itself. We can still do a lot about validation and verification.
I do want to come back to the evaluation and verification perspective, but I believe we were talking about a bit about the emergence capabilities or emergent behaviors of these kind of models. And I believe, Leonor, you have some comments to give about the emergence behavior of the models that you'd like to discuss.
Okay, okay.
Sorry.
Maybe the audience should, no?
Yeah. Okay, we can come back to that later as well.
No, I don't have any comment. You mean the fact that very large language models have emergent behavior that is very different from smaller models? Is that what you are referring to? Or?
Well, in a way, yeah, like definitely that will pose some concerns or issues on quality evaluation, right?
Yeah, but anyway, I'm not sure I understand the question. I'm sorry.
Oh, that's okay. But maybe we can step back a little bit and firstly talk about the evaluation of correctness that we were just talking about. Oh. Yeah, go ahead.
So there's the evaluation of correctness, but maybe if we look at the problem from a different perspective, if we're comparing two large language models, what are the attributes we're comparing them against? Correctness is maybe one, but if, like, there's the probabilistic aspect of the correctness, there are other attributes that we put to quality as well. So there's that emergent behavior. Maybe it gives the information correct, but it consumes more CPU power or whatnot. Or it doesn't give the information correctly all the time, but it's smaller and it's easier to experiment with. So there are different aspects of quality that comes into it. So correctness, when it's probabilistic, by itself is not necessarily maybe enough as the determiner, but I don't think we've really spelled out what might be those attributes. I think Lionel was saying, well, it's like the safety, right? You can expect some of the safety, but there are so many dependencies between the different elements and the attributes, it becomes an exercise of enumeration of those attributes rather than defining what that might be deterministically mean. So.
Actually, I'd like just to say something. You know, when we use large language models, like before when we use deep neural networks, it's not that different, it's just worse. We use them because they allow us to implement something that we don't know how to implement other ways. You know, that's, for example, there are many problems that, you know, vision people have failed to address for decades. And it's only when deep neural network came that they could actually be accurate at it, you know. So it's a trade-off. That is, you use that technology because it allows you pretty accurately, but not perfectly, to do something that you cannot do, at the expense of not being able to prove its correctness, its security, its safety. So the advantage is that you can do something you couldn't do before pretty accurately, sometimes very accurately. The drawback is that you cannot prove anything about it. So that's the trade-off. So if that trade-off is not acceptable, you shouldn't use it. And if you use it, because you need to be a responsible engineer, you cannot just say, oh, well, too bad. From time to time, it will do something horrible, too bad. No, you cannot do that. So then you have to compensate by making sure that you protect the system against occasional mishaps. I mean, basically. So you see, you accept a certain trade-off, and on the other hand, you protect yourself.
So if I want maybe to comment, add something on top of what Lionel was mentioning, in the context of safety critical systems, so some of the project we have been doing with some of the aerospace company, one thing that's very important to them when they try to use these technologies to have a good understanding of the operation domains, right? They know the technology is not perfect, but the goal of all the QA that we do around is to try to get a more precise as possible estimate of what's the operation domain of that technology. And once we have it, then we can put controls around it, right? So in some sense, for sure, when we learn, we train a model, we want to generalize. So we don't want to be stuck in distribution in any case. But at the same time, we know that we cannot use the model out of distribution. So there is this in between that we try to maximize as much as possible, but then we have to do a good estimation of what is the uncertainty and what are the risks related to the use case of the application. And once we have that operation domain, then we can embed that technology and deploy the application. So the part of the QA, quality assurance activity that we do, especially in those kind of settings, is to characterize that operation domain for the technology. And I think with technologies like neural network before and large language model now, maybe it's the best we have at this point, at least in my opinion, but I will let my colleagues react.
Yes, I fully agree with the comments that have been mentioned. Yes, I think it's very important to look into emergent behavior, and emergent behavior can be either good or bad. And I think like the bad example, I think before the large language model, I think there is a bot that has released, if not mistaken, by Microsoft named Tay. Yes. And initially it's great, and then people is teaching Tay to do bad things, and suddenly Tay become very racist and say something that is bad. So that's emergent behavior that is bad. There's also emergent behavior that is good. For example, I think ChatGPT can answer a lot of questions, and many of them are emergent. We're not really teaching them to do that, but it's becoming more general purpose. So I think to deal with this problem, I agree with Foutse mentioned that if we use it within a specific domain, we can characterize that domain, and then we can put that guardrails there. And I think, as also mentioned by Lionel, we can do some kind of like monitoring to ensure that it's follow a certain principles. One thing that may be a little bit more challenging is that if we open it to the public, just like Tay, we open it to the public. And then humans are very creative. And sometimes the emergent behavior is not really what we want, and then there's bad people around. So the question is, how can we really thoroughly test that large language model, especially when it's deployed on the open setting, so that we can ensure that the emergent behavior that is bad is less likely to happen. We cannot guarantee that its absence, but at least it's harder to get there. The attacker needs to spend a lot more effort to get there. And I think there is maybe a cat and mouse problem between the bad guy and the good guy, just like things that happen in the security domain with respect to this large language model security and also prevention of the bad emergent behavior.
So maybe one thing I would like to add is, yeah, I fully agree with what the colleague said, and I think the difference is that there could be how we consider a particular problem, how we find the solutions. So either like, I think there is a recently widely discussed book called System 1 and System 2. System 1, 2 is basically two ways of how we, from a human point of view, find the solution to tackle that problem. So either from bottom up, that we collect the evidence. It's more like a data-driven approaches that we collect the evidence and find the patterns and gradually getting a solution that can achieve that goal. But as the theoretical part of this, it is actually foundational machine learning is a lot of assumptions there. So the theoretical part is missing. That's, I think, a big challenge these days when we develop a neural network or even the transformer-based language models. We don't have a really nice understanding on those, what we have for like System 2. So that we have a top-down design, well-specification, reasoning, this kind of deduction. So we clearly know the capability boundary out there and some things we can't. So there are some kind of a very formal, rigorous reasoning and analysis on that. I think these are actually really big ones, gap there. So in the future, I think Microsoft recently proposed a concept called semantic kernel, and basically is try to make a hybridization of both techniques in one software development. So I think in the future, maybe we need a more stronger way for analyzing the system that contains both of these software components. Yeah.
So I guess I'd say that in the context of this emergent behaviors, or even broadly speaking, one of the things to see is like, what is our understanding of how something like an LLM or ChatGPT works? So as long as sort of we have that understanding correct, so that sets our expectations of what do we expect it to produce as a result of our queries. So I'll give one example from about a year ago. It's probably the current version is different. So I asked the free version to prove that square root of 2 was irrational. So there are many textbook proofs all over the internet, so it was very easy for it to give me a proof. But then I asked it prove that square root of 64 was irrational, and then it did construct a proof for that as well, following the template style of proving that square root of 2 is irrational. So, but was that surprising? Should I be, disappointed? Maybe not, because that's sort of how the system is designed to work. But then, if you can get into a conversation and you can provide it a bit more information, you can say that no, it's not irrational. It's 8 times 8, and then you tell it it's a perfect square. So then, the next time you ask it to prove that square root of 9 is irrational, it says no, 9 is a perfect square, therefore it is not irrational. So okay, so but again, I think the point I want to make is sort of we need to set our expectation of in terms of what are we expecting it to do for us. So, we should clearly not expect it to do magic. But yeah, we should try and understand what its strengths are and where its strengths can help us solve a problem in the domain we are working in.
To add to that, I could not agree more. What do we expect these tools to do for us? And I don't think we should shy away from saying for particular kinds of problems, they are not good. This does not mean we don't believe in them. This does not mean we're going to continue to apply them. But for certain kinds of problems, they will not be well suited. And even by saying that, we are implying quality, correctness, and some of the attributes. And I think that's important. Our excitement somehow getting ahead of, we're almost scared to say they don't work in some cases. They will not be applicable to some cases.
Yeah, I definitely agree that, and we are seeing a lot of positive energy in the field and excitement around moving the software even more and more autonomous in this direction, going towards agent or multi-agent interacting system, which I believe is even more complicated in this case because we were talking about putting boundaries, defining scenarios, and understanding internals of the systems. But if we are thinking about autonomous agents and how they interact together to solve a problem, the internal mechanism becomes super dynamic and cannot be even decided beforehand, given the wide range of things they would be possibly doing inside, or even the tasks they were given. So what do you think about this direction of autonomy and the quality part of it?
Well, my view on this is I think we need to design better agents. That's right. Because I think as soon as, so this is a discussion I'm having with colleagues who are more on the AI side, and we're on this roadmap for AGI thing. For them, the goal, which is the goal of AI in general, is to build autonomous agents, right? So to build entities that will be able to self-evolve based on their interaction with the environment. But then I think if we are in a multi-agent scenario where we have such entities, on the QA perspective, I don't think we can control them from the outside, so, right, based on the interaction. So I think in that setting, it will be important that those agents are built in a way that provide them self-awareness and control so that the agent can also control its own behavior. I don't believe we're close to that yet, but I think it would inverse the quality control. Instead of controlling from outside, they have to be controlled from inside by design. So those features and those characteristics needs to be implemented by designing those agents to enable a safe interaction of a multi-agent system. I hear a lot of debate on the AI safety field nowadays, which is in that direction. But yeah, I mean, that's my view on that. I'm not sure we can do QA from outside if you have autonomous agents. Yeah.
I fully agree with Foutse. I think with autonomous multi-agent, there is a lot of unsolved problem. And if agent becomes closer and closer to AGI, and I think it creates a lot of issues as well. So one thing is, can we verify a human being? It's very hard, right? And if the agent becomes more like human being, can we verify their behavior? Is also very hard. So I think there will be maybe a new kind of a reality soon when we're going towards agentware, especially towards AGI. So if we cannot verify things, how can we make sure that things goes well? So how do we interact with humans that we can't verify? We don't even know like the intention of the other humans. So maybe we need to learn from maybe back to like psychology and things like that. If the agent, as Foutse mentioned, can be self-introspect and then make sure that it is designed well. Another possibility is maybe the agent can check each other, and then maybe a collection or coalition of agents can actually make sure that the system is good, accomplishing a certain objectives. But also in multi-agent, there is this thing called reward function. And the reward function of different agents may be different. So let's say there is agents from 3 different companies, one from Huawei, one from Microsoft, one from IBM, working together with a developer. Each of them has different reward function. How does they work? So I think a lot of interesting open questions out there.
For sure, I definitely agree. Oh, yeah, sorry. Yeah, we can take some questions from the audience as well. Yeah, Gustavo.
Hello. I have a question to the entire panel, I guess. I'm seeing a bit of a paradox, and so I want to ask this because maybe I'm just crazy. So imagine our age. So we saw many problems, right? So there are problems with the benchmarks, and writing prompts is hard. But imagine we solve all these problems. So we reach a point where we have great multi-agent systems. Devin AI does 80% of GitHub issues, right? So super effective AI. So basically, I just talk to it, a few back and forth interactions, and then it figures out my intent and solves the problem, right? But it's not perfect, right? It's never going to be perfect. So what happens then when all of a sudden I see a bug in production, and now it's a code that I basically never saw, or maybe I reviewed it, but I never really understood it because, you know, now that the agent is so good, I don't need to be in the loop as constantly, right? So thinking more from this software maintenance perspective, if we have awesome agents, then what do we do in terms of maintenance when, just imagine when you jump into a new project and you don't understand anything about it. It takes a while for you to catch up, right? And understand the architecture and anyway, so what are your thoughts on this matter?
So your question made me recall the jokes we have. Call people from retirement so that they will help you. So understand what they were thinking 20 years ago. Who do we call from retirement?
Exactly,
When we have those kinds of, well, I think it's a good question. And maybe one thing now that we're asking these questions is what traces do we leave within these tools or the data that is being curated as part of the large language models to make maintenance easier, sustainment easier is one perspective. The other perspective is this has been such an intriguing and knowledgeful week. I don't know when this was discussed, but in one of the discussions, a point was made, maybe you don't maintain, you regenerate. Because regeneration has become so easy, that becomes a solution. And I don't take credit for this. Unfortunately, I forgot which colleague had mentioned this, but yep. I thought that was actually brilliant perspective because now economies of scale have changed with these
Exactly.
tools.
Yeah.
And maybe the agent actually can do the maintenance itself, right? So maintenance agents possible. I guess if we can steer this paradigm a bit further and further if we want it. But
Yes, I fully agree with the comments made earlier. I think we should focus more not only on code generation, but also maybe on maintenance and other things. And yes, but also one possibility is the software of the future may not look like the software today. Right. I think Ahmed earlier mentioned that maybe in the future, everything, there's no more code. There's just like models out there. And all the programming language we have is all meant for human, talking to machines.
Yes.
When machines talk to machines, do they need a programming language or they can communicate better? I think we have this domain name, right? www. something. That's for us. And then for machines, everything is numbers. Right. So I don't know in the future when the role of humans getting less and less, machine more and more, machine talk to machine, do they even talk in Python? Do they talk in Java or they talk in another language?
Right.
I think it's like an interesting new world out there that maybe will be coming there in the near future.
Thank you.
Any other questions from the audience? So maybe continuing on the comment by David, in that case, when we're actually seeing brand new ways of communication among the new generation of software, how would regulatory requirement come in? For example, the transparency of this kind of system, would that become? Do we think that these kind of requirements still needed, and how would that impact these kind of systems?
I think when the more automation happens, I think we really need more controls. I remember a talk, I think a keynote by Peggy Story at AAC. So he said that automation sometimes does not help because like with automation, the user of that automation need to be actually more capable. Imagine there is a product line where you have building a car and then the mold has a problem. So within a second, you produce like 1,000 pieces. So in the past, when you make mistake on one piece. Now with automation, you make mistake on 1,000 pieces. So I think there is need more for regulation and control. So the question is like, how exactly we control things that we cannot even define at the moment. So I think like there's a lot of thinking is needed. That's why we need a lot of discussion like this, like exactly what we're going to build in the future. And after we get a glimpse of it, maybe we can put some more control there. But I don't think it would be waterfall model, more like iterative model. We want to build something, we control it, it fails. We build something better, we control it, it fails. But with the pace of AI, this cycle needs to be faster to make sure that we can really control this beast called LLM, FM, AI. Just my 2 cents.
Yes, Sir Ipek, would you like to give the comment first?
Sure.
Yeah.
I think along with one question, answering the question with a question is probably not fair, but who regulates is probably a question that is not as easy to identify in this domain because who owns the data, who owns the tools, there are so many parties involved. But I think as a consequence of all of these, we'll definitely see proprietary models, internal models, which kind of puts the regulatory responsibility within the organization and whose data it is, and that will probably change the way we're asking these questions.
Thank you. Yes.
Yeah, we see this summit. Most of the talks are coming from researchers and practitioners in software engineering, computer science domain. But we are talking about a system that will be training models that will try to give a kind of human-like abilities to machines. That's already something in anthropology they call anthropomorphism, which is a great concern, and it's driving towards AGI. Now, if we focus only on the technical aspect of it, and we don't bring in social scientists at this high level of discussion, we might be running a risk because the agents that we are training will pick up behaviors of high-skilled technical people. And interacting now with commoners could be a potential problem that we might now restart a new problem to solve. So I don't know why we can not reason. We see it already like in prompt engineering. You can query a large language model depending on the prompting. Someone with a high skill of writing prompt will have a different set of response. And we could see that across different domains that this kind of problem is origin. So my problem is, why not engage those kind of stakeholders to see a broader problem, and then we see how we could start solving it, even if we have to focus on the technical or the software engineering aspect, knowing the broader problem ahead. Thank you.
Well, it's a good, I think it's a good point, but what I would like to say is, of course, in this summit, we're focusing on software engineering domain because we're talking about building software, but I'm aware of some work where people also have been exploring access to technology like ChatGPT for the broader public, right? And they have also worked looking at prompting strategy for ensuring that we democratize access to this technology. And also, we have been all witnessing this debate on the regulation of AI over the past, I would say, 2-3 years. It accelerates. And most of the people in this debate are actually social scientists and jurists, right? They are not software developers. And I think this is healthy in the sense the public is looking at the technology, and we should thank ChatGPT for this. I think once ChatGPT hits the main public, became mainstream, people realize actually the capability of what was already installed. That's people working on the technology already knew, but the broader public had access to the technology, and this sparked all this debate about the risk that the technology will pose and what regulation we need to put in place. This to say, I don't think we are like just in a vacuum here. I think the debate is also happening with the main public. We have regulations that are coming in force. The EU Act is passed, and the EU Act comes with very biting regulations around what company releasing software with high capability functionality should ensure to protect the public and to ensure that the system that they are providing still benefit the public. I don't think it's perfect, but I think there is a debate ongoing. That's just my point. But I also agree that it's a very important point. We need to remain aware of this important aspect of the system, because the reason of building software is to provide services to end users, actually, to support our users. Yeah.
I believe Albert has a question.
Okay. So yesterday we talked about how things like Copilot are here to exist, and we need to figure how we can make them help us better, become more optimal how we use them. Okay. With that in mind, that means that automatically generated code will become part of our daily life in a software production company, a software company. So two things about it. So, based on, say, Foutse's work, he said, the way they write code is very different, or at least producing different type of code signatures, okay? And second, they can write code way faster than any human can. So my question now is, what are things that software quality work really needs to be rethought given the speed and the different characteristics? So a lot of things we knew about how bugs exist. Maybe is it true that they're going to have very different types of bugs? Can we speed up testing, everything down the pipe? Any thoughts on these, or it's business as usual because they're trained out of code written by human at the beginning?
I think you have to differentiate at least two cases. The case where the technology is used as an assistant and a human in the loop, and the case where it's an autonomous agent. Those are two very different situations. For autonomous agents, I'm not sure if the problem is very different from the problem of verifying autonomous systems. It doesn't matter what the internal technology is. You have an autonomous piece of software that is acting on this environment. And of course, there are issues associated with that you have to deal with, but that's what we've been dealing with, for a long time with autonomous systems. Now, when that technology is used simply as an assistant and there is a human in the loop, the problem is very different. In that case, what you want is not to ensure that the agent doesn't damage human lives or the environment or whatever. In that case, you just want to make sure that that technology is not a waste of time for the human in the loop, that actually there is a benefit, So then, of course, the validation of systems based on that technology is very different for autonomous agents and assistants or recommender systems, whatever you want to call it, But I don't know if it's very different from what we were doing with autonomous systems or what we were doing with recommender systems. I'm not too sure there is a big difference, except for the fact that there is no, well, it's not a detail, I guess, except for the fact that it's a black box. But I guess it's not a detail. I mean, it has an impact on what you can do.
One of the benefits that these models are bringing is they're able to search at a vaster space, much larger space, and be able to come up with more alternatives. So, and because they are able to do them faster, even not better in some cases, there's the scale implication. But what if they're not creating more code, but we're able to say like, well, do this with simpler code, less, and we're able to, in fact, reduce the scale, which then becomes easier to check. So I think we make assumptions that everything is going to keep growing, while the data, of course, the models perform better when there's significantly large amounts of data, but with that maybe comes outputs are a lot more simpler and more elegant in design, for lack of a better analogy, which might help us to assess them with existing techniques, or even if we have new attributes with them. So I think those scenarios are still also a possibility, since we have the ability to search the design space in a larger corpus. So maybe we'll see some examples of those as well. Not just huge scale, but more manageable scale might be an outcome.
I fully agree. And one thing I would like to add up is I think these days the simulation environment is a very important part to help us mirror what the domain-specific task is. And under that context, it provides us a way to provide more deeper evaluation on the potential things happening there, and especially the digital twin transformation. So if we know the problem model well enough, then it definitely provides us more capability to assess how either the code or the agent react in that system, have a better safety evidence for those users who want to use it.
I fully agree. I want to also add, I think Ahmed mentioned that there is the, I think food stocks say that the code that are generated by ChatGPT is actually different behavior than the code generated by humans. Maybe they have different errors, and maybe this creates a problem. And I remember a talk yesterday by Tom, actually, when they interviewed people or survey people about GitHub Copilot. Initially, the responses are not always positive. There's one person I remember, if I remember correctly, the person say this may introduce certain kind of relaxed behavior on developers. Developers just trust whatever code that they give, and then at the end, there is a lot of error coming there. And I have a nice conversation with Ling Ming as well, and he gave this illustration, basically he was trying to transpose a table, during the Shonan meeting, I think he relayed this, And then what happened is that really the large language model transposed the table for him, but it changes several values in the table. And if you're not careful, basically those values are important values that you change. So again, I think there is a new element of quality here that is, I think, related, I think, to both Tom, I think Ipek's presentation yesterday on like over-reliance or like too much trust that we give to this LLM and AI systems. And that may be a new quality aspect. Like if we give too much trust to it and it does not do what it's supposed to do, then it may create a lot of problems. So how do we actually calibrate this level of trust, and how we design mechanisms so that that wrong level of trust is there? I think it's an interesting problem to look at.
Yeah, I totally agree. And like I said in my talks in the morning, I think when we use those tools, if they generate artifacts with signals that are unusual for us, and if we have over-reliance of what they are bringing us, I see a risk of perils in the sense that we may end up with more unreliable artifacts slipping through the development pipelines. So in this sense, I think we need to first continue this type of probing studies on their behavior to get a very good understanding of really what they do and their different failing modes, so that we can adapt our QA techniques, right, to make sure that they can capture this type of behavior when the model misbehave, and also that the users of the tools can be aware of this type of issue, so that we don't over-rely on those things. And I think the problem will probably just go increasing and increasing as we are adopting different type of models trained differently. For example, in our study, the 3 models that we study have not been trained following the same methodology, right? So, and I think this is likely to be something that will compound and it will keep increasing. So it's up to us to kind of be aware of this and make sure that we build the right tools, especially in this scenario where the tools are helping us. And as Lionel mentions, if we're in a scenario where the tools are totally autonomous and then doing things without our interactions, then maybe that's a very different setting, and the type of problems that will emerge in those cases may be different. That's it.
In the specific context that Ahmed mentioned, maybe another thing we can consider is that the developers who are using large language models or ChatGPT to help them implement their code, perhaps it's also a matter of educating them on how to better use these LLMs. For example, like, if I want to synthesize a code snippet and use that in some context that I have in some code I'm developing, I should be aware that there are many possible candidate solutions that a system like ChatGPT can create. And then I could also perhaps guide it in terms of creating a code segment that may be more amenable to analysis. So that would be a very interesting way of using something like ChatGPT. For example, it gives me some initial answer, and perhaps I can ask it, could you create something functionally equivalent with fewer lines of code, or with fewer loops, or with fewer nested loops, and stuff like that. So I think part of the problem maybe can also be addressed by sort of training the users of these LLMs in order to how to get the most out of them.
Thank you. Any other questions from the audience? Yes, Yasu.
So yeah, education. So now we have a foundation model then for the software quality. So, but in university, there are like several courses about the software quality assurance. So for our degrees. So how educate should change for that like degrees? Like are there any like a comment or like opinion like how like a course should change in our degree because of the foundation models?
Okay, so yeah, maybe it's a very interesting question how they should change, and it's a hard one to answer quickly. But I mean, I can give one example of like how one of my classes actually changed. So I teach a class on software testing, and of course, you know, every student is very curious about ChatGPT and whether they should use it or not use it. And then, so, you know, I don't have any specific policy on trying to ask them not to use it or to use it, but I show them some ways of using it, some ways where it's useful, some ways where it doesn't work. And so I think that would be one way of, like, you know, just trying to make them become better users of ChatGPT so that they can use it to learn different concepts, or like programming languages, or like, you know, how to write or test code. And then also to try and expose the limitations of the system, because if you're a beginner user, it's natural to put too much trust into something like ChatGPT and just to believe whatever answer you get. So then it's very important as, like, you know, a teacher perhaps to show students simple cases where things fail. And I gave one example of, like, you know, showing that something is irrational. But there are other interesting examples that you can also come up with. And then there are some more, you know, just fun things you can do. For example, ask it to create the smallest question it cannot answer. And so, you know. But yeah, in terms of, like, you know, we need to acknowledge that it exists, and we need to see how to make most of it. And in education, I think it has great applications in terms of making students understand complex concepts. It can be a very good teacher for students.
I haven't really tried to use it in my class, so please take my comments with a pinch of salt. Yes, so I think I like the conversation with Safras, and Safras shared that the daughter actually, the teacher actually gave like essay and asked to critique. So I think we can do it for our programming class as well. I was thinking of doing it for the next class that I teach, is like asking them to take a look at the code that ChatGPT creates, and then maybe ask them to critique in terms of like the efficiency, in terms of the naming, also in terms of like many other bugs that that code may actually have. And maybe this can help to be able to enable the student to actually get a lot of examples, and then they can critique and get better. I think ability to critique a piece of code and understand whether it is good or bad is an essential skills in the era of, I think, large language model with software engineering, because large language model can produce something and we need to know whether it is good or bad. And I think another thing is, like, I used to teach a software project class, and last time, sometimes we cannot scale up the project too big because the student have limited time, but maybe with the productivity that they can gain using this large language model, maybe we can ask them to imagine, and then we can ask them to interact with this large language model. I remember during the Future of Software Engineering track of ICSE 2023, many of the speakers actually asked ChatGPT what is the future of a particular domain, and it's quite interesting that ChatGPT answers is quite cool. So if we have an open-ended question for the student, let's say for software engineering, we can ask ChatGPT what kind of software is needed the most in the world that I can do in 4 months. And maybe they can engage in a nice interaction with ChatGPT, and then they can be equipped to be software engineer of tomorrow that has this capability to interact well with foundation model to create better software for everyone.
Okay. I totally agree with all my colleagues have said. And I think if we even come back to the problem that we were discussing about over-trusting or over-relying on those tools, and I think one way to also solve that is to make sure that we teach the students embrace this reality a bit early on during the training process, so that they also get a better understanding of what these technologies are about. Because in any case, as a developer, they are very likely to operate in an environment where they will be having access to these tools. Right? So I think on that sense, my position would likely be that we should embrace those technology in the class. And on the other side, generative technology, I think, has a huge potential in the sense that they can also even support our educational goals, right? We can use the tools to actually generate, as David was mentioning, different kind of examples, right? Different kind of tests, different kind of scenarios. So you can actually enrich the learning experience in the class, right? In that sense. So yeah, that's my 2 cents on this.
Well, I am the only one in the panel that does not have a professor in front of her title, so it's very easy for me to pontificate. But from an observation, as someone who's hiring these individuals to her team, one of the things I think the current education system fails to teach even is We're teaching things greenfield, yet the reality of software is brownfield. When these individuals get into wherever they are into the job, they have to deal with a large code base, they have to deal with evolving a code base. So the reality of where they're starting is the way. So I think we can apply the same analogy. What is the reality of the starting point of the software going to be, which is a black box because you don't know where the code is coming from, or you're interacting with these tools. And with that, increasing the skills of the students in terms of ability to ask the question, why am I using this tool? What is the purpose and what's it giving for me, and how it applies to the current context is unfortunately an underestimated skill, and not a lot of students, wherever they are, they don't come out with that skill. Of course, it's also an outcome of experience. It doesn't happen in 4 years. It happens as you see these examples, but I don't think we should underestimate the value of seeing something that is existing and you're building on top of it rather than starting from scratch. And these tools could be utilized in either ways as a skill set from that perspective.
One minor thing I would like to add up is that I think this is super important to let the student get comfortable when this tool involved, because eventually during that working environment, they will, in those and these ways, definitely be somehow interact with these tools. And starting at an early stage, will be very important for them to get ready for their next stage in their career path.
It's like you're fixing somebody else's bug, but you might be able to trace the person. Now you're fixing a bug that you don't know where you might be fixing, or there might be all those consequences. So it's like the root cause analysis might become significantly harder, or more important, or irrelevant if you can regenerate. So those, I think, are both scenarios that we might need to investigate with.
Thank you. Yeah.
Yeah, it seems like it's closing to an end, so let me maybe ask something controversial. So let's try to see if there's anything interesting coming up. So like the example maybe I first drew is for YouTube videos, right? So sometimes if you get bored, you watch one, and then you look at the panel, they recommend something which is similar or related, you watch, and then you keep watching, hours and hours pass by. But then you realize you're watching something which your own interests are, or something, which you kind of already have some knowledge on, right? So then goes to this foundation models or co-pilot kind of thing. So they give you suggestion, you accept, you do it. But remember, foundation model was trained on data set many people worked on the GitHub. So in other words, like our source or our interests tend to converge. So if we continue doing these kind of recommendations and so on, would we end up, the same kind of intelligence level as, the average person? And there's no way of actually thinking beyond what's already out there before. So in other words, we need the people, like, the kid outside telling, the king does not wear anything, he's naked, and have a different way of thinking. Do you think, how can we get away from this kind of recommendation problem? We're basically stuck in the comfort zone, and we are not feeling comfortable to kind of looking beyond, saying what can be better than currently already exist in the GitHub data sets and so on.
I think that's a very interesting question. And I think with this large language model, I hope we not just like constrain our ability to think just because of the large language model, but I hope that with this foundation model, a human can actually abstract one level higher. So people can like maybe don't care about how exactly to write for loop, but just express their intention. Like, for example, I'm very bad in drawing, but I think I have a good imagination. In the past, I cannot express it in drawing because I cannot draw. My hand doesn't sync with my imagination. But now with the prompt, I can actually express what exactly I want, and then voila, come a very nice pictures that I cannot draw, but I can ask AI to draw. So I think my hope is that in the future that these tools, although they learn from the past, they can adapt with new things that humans create with the aid of such tools. And at the end, the recommendation of tools can improve over time, because I still believe that humans are more creative than the tools, at least at the moment. And then actually humans can abstract away those lower level tasks and create higher level tasks. Like now, none of us know how to create a fire. If there is no more electricity, then we are doomed, right? So, but we have abstracted it one level higher. We know how to master electricity, and then we can create things that are much better. For example, lamps and like projector and many other things, right? So I think there will be a lot of exciting things out there that can go beyond coding that maybe can be powered by these foundation models. Just my 2 cents there.
So I kind of agree. I think everything that is automatable well, so easily, maybe it's not something we should be focusing most of our creative energy on, right? So I agree that with this more and more capable helper, we will have less and less to spend our energy on repetitive tasks. I mean, I know a lot of people enjoy programming, and then sometimes they appreciate being in the flow. But there's also a lot of things around programming that's pretty boring and repetitive, right? So in that sense, having capable tools that could generate those parts and support those parts of the programming process for us, I think it's freed us from those tasks and leave us the opportunity to be more creative, to think about other things, and raising the level of abstraction in that sense. And going forward, my thinking is more that this will be teammate, like co-pilot, right? So we're having those models working with us. Imagine what it's like accessing your Wikipedia store on a hunch. So large language models, the way I see them is it's a compressed knowledge, right? So you have all this data compressed in one model that can give you access very easily to that information. But now it's on us to retrieve that information and build better and raise the bar of abstraction and climb the ladder. So I don't feel like we'll get doomed out of this. But of course, we will lose certain skills on certain repetitive and boring tasks. Now, is that good or bad? So it's up to us to of course, if we lose how to light the fire and then there is no more electricity, that's definitely a problem. But I think as a society and collectively, we probably will figure out how to best use those tools.
So I think you bring up a critical point, because there is the data bias and it's feeding back into it, which might get limiting after a while. We don't know when we'll reach that, and it might reach in some aspects, but not on the other aspects. In design fields, the very first thing that is taught to the students the first year is different techniques to trigger their creativity. They're given the different tasks to do with different kinds of constraints. So maybe because we are now foreseeing that risk, we need to teach ourselves and our students, going back to the previous conversation, different ways of questioning and being creative. I think there was an earlier point about the social sciences aspect. We should definitely not just rely on the tools, but develop skills in terms of recognizing when it's getting limiting, recognizing when it might be starting biasing, because it's a recognition. Like we recognize because of the domains. Now, how do I recognize that the recommendations I'm getting are not necessarily moving in the right direction? So those skills will need to be developed, not just rely on the tool. And now that we're envisioning this, again, we have the responsibility to maybe think ahead and see how we can instrument both limiting the biases, or can we actually create alternatives and also teach those skills to the end users. I think there are both aspects of it. But I agree with your point that there's going to be a recommendation bias that is coming out of this eventually.
Okay. Okay.
Yeah.
I had a question.
Probably the last one.
Okay.
But yeah, go ahead.
Okay. So, like hallucination. Okay, so we spend a lot of time when it comes to quality saying hallucinations is something that's bad, and we're doing all this quality control on hallucination. But another way is actually hallucination brings a lot of innovation, right? So For example, when GPT hallucinates and creates a whole API for you, maybe it's a sign that a normal, average, smart person would think that this is a good API, and maybe we should actually improve the quality of our software and create these APIs. So the question to the panel, what are your thoughts? Is there any ways we can use hallucination capabilities to actually be a good thing and to improve quality of software?
Damn, I should have written that paper, right? That's like when it recommends not existing references.
Interestingly, I have a discussion about this. Like last week, there were a number of visitors from Tel Aviv University, and we were debating about hallucination and what's the difference between hallucination and imagination, right? So, like a person that hallucinates a lot is very imaginative, is beyond normal, right? Yes. However, what's the difference between the two? And then I think one interesting difference is that the person that hallucinates does not know that the person hallucinates. But the person that imagines knows that it's something that's not real, but it could be a reality. So I think, how can we inject that kind of level of understanding within the LLM so that it can know that, hey, this thing does not exist, but this can be what will happen in the future. But making that exist inside the foundation models is I think, an open challenge there. Because at the moment, I think the foundation model just learn from a lot of data and then creates things that may or may not exist without understanding whether it exists or not. So I think it's an interesting direction for future work.
If I could add something on this, I think the challenge currently is to sort out the good and the bad hallucinations, right? So I think among the hallucination of the models, there are some that potentially could be considered like creativity, an opening path that could be exploited and generate new content. But also there are some other hallucinations that are just erroneous, not good. So if we could improve the models and so that the model could leverage this capability and think outside the box, but in a controlled way, I think we can be on the path of the creativity. I think right now the challenge is that the model, the hallucinations are so unpredictable, and the context in which they appear, it's uncontrolled. So we can have very damageable hallucinations and some benign hallucinations. So I think more studies, and if we get a better understanding of controlling the imagination of the models, then I agree that there may be creativity in some hallucination, in some sense. But currently, we just don't have any structure in that space of hallucination occurrences.
Yeah, so I fully agree, and it reminds me a title is not a bug, but it's a feature. Yeah, so I think it really depends on the context. For example, in the natural languages and code, then the hallucination can really be an important thing that create untruthful fact. And then I think we can have some external ways like a database or other knowledge base have cross-check these kind of behaviors, whether it's really true or not. But then on the end, I also fully agree this is a opportunity to create more creative things like what I can think of maybe in some like a robotic control planning. Those are rule-based. It's really hard to well-define for a particular task. But with this emerging hallucination capability, that can even explore more space that to see and create new kind of solutions as a reference. Might not be eventually the selected one, but this can be a reference one to pick up.
Yeah, I would also take the view that hallucination is not necessarily a bad thing. I mean, if you think about some of the earlier technologies like genetic algorithms, so there's that mutation operation, and so also in certain optimization problems you might be stuck in some local minimum, and to get out of that, so if it was a minimization problem, so maybe hallucination is sort of a generalization of a similar concept. And but then of course there can be things which are obviously contradictory, so there should be some ways of checking those, but perhaps certain other things could be used as seeds for improving the answer.
also probably brings up the concern that what is the ground truth? If I know that it's hallucination, but it triggers creativity, is a different path versus it's a hallucination, but it introduces failure. So what are we checking against, and who's doing that checking against is probably something that would need to be figured out. But I do agree that it's intriguing. It's like, well, is it a feature or is it a bug? I like that. That's a good analogy there.
Awesome. Great. Thank you so much for the panelists. And I think it was an awesome discussion. Let's give them a round of applause. Thank you.